So the plank or the beam should also be having some weight. And since it's a uniform beam, so the weight of the beam would be exactly in the middle, which is at 1.5 mark. Sorry, 1.5 meters. And the weight of the beam is 50 newtons. That's the weight of the beam. So how many forces do we have? I think we have only two forces, and the system is in equilibrium, which means we can apply the principle of moment. This is our pivot. For that pivot, this force would be clockwise and this force would be anti-clockwise. So let us write the expression first. For anti-clockwise force, which is W times W times the perpendicular distance from pivot is 1 equals the clockwise force is 50. The perpendicular distance of the other force from the pivot of 50 Newton force, which is the weight of the pivot, the perpendicular distance would be this much, only this much, which is 1.5 minus 1. This is the perpendicular distance from the pivot. So 1.5 minus 1 would be 0.5. And if we calculate this, 50 times 0.5 would be 25. Okay, so let's move on to the next one. A mass of 500 grams is attached to one end of the rod of the total length 1.5 meter. The rod is pivoted at a distance of 25 centimeter from the other end. So 25 centimeter, I mean the other distances are in meters, so I can convert it into meters. So 25 meters means 0.25. Sorry, 25 centimeter means 0.25 meters. The rod is horizontal, which means it is in equilibrium. What is the moment about the pivot due to the mass? So we simply need to find the moment produced by the mass about the pivot. The moment produced by this force about the pivot. But then it has to be divided by 1000 also, because it was not grams, it was just grams, not kilograms. So in kilograms it is only 0.5 kg. Or alternatively, you can simply multiply 0.5 by 9.81, which is 4.905. So this is the force that we have. Now what is the moment produced by this force? Moment equals to force times the perpendicular distance from the pivot. So what is the perpendicular distance? 1.5 minus 0.25. So 1.5 minus 0.25 would be 1.25. So let's write it on the calculator. We get 6.1. So we get C as the right answer. A uniform, so uniform means weight is exactly in the middle, and I think we don't have any useful information in the description. We can see everything on the diagram. The bar experiences a resultant moment about P of 6 Newton meter in clockwise direction. Means there is a clockwise moment of 6.0 Newton meter more than the anti-clockwise moment. You need to find the magnitude of F. Alright, so first of all, we can locate the pivot and the pivot is P. P is the pivot over here. How do we know? It's written over here. Pivoted at P. How many forces do we have? We have 1, 2, 3 forces. And there should be a weight of the beam also, but they have said negligible mass. So rigid bar itself has no weight, negligible, almost zero. So we're not going to consider the weight. Otherwise, the weight would have been in some place in the middle, or exactly in the middle for the uniform rigid bar. Now let us point out the problematic force. This force could be problematic because this force is not perpendicular to the distance. So what could be done? We can resolve this force into components. So one of the component could be over here and the other component could be over here. So this component would have been F cos theta connected with the given angle. The other one would have been F sine theta. And F sine 30 is, by the way, 0.5 F. Because sine 30 is 0.5. So how many forces do we have? Well, the first one is this. The second one is this. And for the force F, out of the two components, we're going to use only this one, because only that component is perpendicular. Now let us label the forces clockwise and anti-clockwise, considering P is a pivot. So if P is a pivot, this one would go clockwise, this one would go anti-clockwise, and this one would also go clockwise. And we also know this thing, that the resultant moment is not zero. What does that mean? It means the sum of clockwise moment do not equal to the sum of anti-clockwise moment. The sum is not equal. Matter of fact, clockwise moment is greater than the anti-clockwise. So what is a clockwise moment? Clockwise moment is, let me write over here, clockwise on the left side of the equation and anti-clockwise on the right side of the equation. Let's do it this way. So what do we have clockwise? 16 times the perpendicular distance of that force, which is 0.30. Sorry, these two are not equal. This is the first clockwise. Plus the second clockwise is 0.5 F times the perpendicular distance of that force from the pivot would be this much. How much is that? 0.6 plus 0.3, which is 0.90. So this is the sum of clockwise, and we subtract the anti-clockwise moment from this one, and the anti-clockwise would be 20 times 0.30. Now this is the resultant moment, and the resultant moment is 6.0. So whatever the clockwise moment is, and you subtract the anti-clockwise moment from it, the resultant would be 6. This is what we mean, this is what the last statement gives us. How do we know we write clockwise first and then subtract anti-clockwise from clockwise, not the other way around? Because the resultant moment is in clockwise direction, which means the clockwise should have been greater. So let's do the mathematics here. So I'll try to write all at once if I could. So it should be 6. Let me write the fraction first. 6 from the right side plus 20 times 0.3. And then minus, the very first thing would also be subtracted. 16 times 0.30. Brackets closed. Divided by 0.5 times 0.9. We get 16, which is the option C. The forces exerted by the people on the gate are shown. So everything else is on the diagram. What is the total moment about the hinge due to the forces F1 and F2? This is a question, and everything else is given on the diagram. We need to find the total moment produced by the forces F1 and F2. The only problem is the two forces F1 and F2 are not perpendicular to the pivot. Sorry, they are not perpendicular to the distance, or distance is not perpendicular to the forces. So we'll have to resolve either of these two into components. So what I can do is I can resolve force into components. So if I draw the components of F1, you can do it this way. The force F is being exerted at this point, and the two components would be one over here, the other one over here. So if you struggle with the forces, you can extend the same force upward. So you see, this is the direction of the force F1. We can also extend the force. And then when I draw the two components of the force, one would be over here to the right side, one could be upwards. Now if this angle is theta, then this angle would also be theta 1, because the angle was theta. The force was F1. So the component that is perpendicular to the angle, perpendicular to the distance, this component would be F1 sine theta 1, because this one is not touching the angle directly. The other component is touching the angle directly. So likewise, if I resolve the second force into components, I could extend the force. One component would be over here, the other component would be over here. This angle would be theta 2. Once again, this angle would be theta 2. So the component that is not touching the angle would be sine. So what is the first moment? What is the moment produced by the force F1? Well, first of all, if this is a pivot, that moment would be anti-clockwise, and the moment produced by the other force would also be anti-clockwise. What is the expression for it? F1 sine theta 1 times the distance d1 plus F2 sine theta 2 times the distance d2. So force F1 and d1 and sine theta. So let's check out the option. It's not cos theta first of all. The moments were not being subtracted. So B is the right answer. So instead of writing F1 sine theta 1 then d1, they have written it this way: d1 F1 sine theta 1. It's exactly the same thing. If you're multiplying the three quantities are being multiplied: f1, sine theta 1, and d1. These three are being multiplied. You can change the order. The answer would be same. And likewise, f2 sine theta 2 d2 can also be written as d2 f2 sine theta 2. But the key indicator is the moments were being added and it was sine instead of cos. So let's check out this one. A non-uniform rod, which is also apparent from the diagram, the center of gravity should be more towards the left side because there's more mass concentrated on the left side. So the mass of the rod is 100 grams. I can draw it over here. Mass is 100 grams. The arrow is not for the mass, by the way. Mass is a scalar quantity. So arrow is not for the mass. Arrow is generally for the weight of the rod itself. So what is the weight? First, you can convert it into kilograms, and then you can use W equals to mg. But I may not even convert it into newtons, because on the other side we also have mass. So instead of using F1 d1 equals to F2 d2, we can apply the principle of moment in terms of mass. It is in equilibrium, so we totally have the warrant, we totally have the permission to apply the principle of moment. How many masses do we have? So one over here, the other one over here, and there could be a force due to this chain. There could be a force due to this chain. And then the question is, what is a pivot? In this question, the pivot is not mentioned. So I should write it as the important point. Pivot not mentioned. This is a case when pivot is not mentioned. So what do you do when pivot is not given? So you choose a point as a pivot where you could cancel a force. So you see the force that would be there in the chain, or the tension in the chain, we don't have any value for that. So we should try to get rid of that force. And the best thing is, if you consider this point as a pivot, then whatever that force is, that force would pass through the pivot. In that case, it would not produce any moment. So we'll consider this thing as a pivot. So this one would be anti-clockwise. And this thing over here would be clockwise. So what do we have? Anti-clockwise was 100. Times the distance would be, matter of fact, we need to find the value of distance d. However, this distance would be, you see, from here till here. For the principle of moment, we need to use this distance. But what we know is that the total distance on the left side is 25 centimeters. 25 centimeters. And the distance on the back side is d. Then what is the distance? This one, it should be 25 minus d. equals 60 times the perpendicular distance from the pivot for that mass is 25. So let's do it this way. 100 can stay there. Sorry, 25 minus d can stay there, all of it. And we can take 100 to the other side. Or you can also do it this way. 25 1 and then 25 4s are 100. And then at the same time, you can take, or you can cross out 60 with 4, which would be 15. So 4 15s are 60. What are we left with? Left with 25 minus d equals to 15. And then what? Let's take d on the other side, so it becomes positive, and we bring 15 to this side, and it is subtracted. So 25 minus 15 would be 10 centimeters, which is the option A.